The stereochemistry of radical substitution reaction. Here is butane, which undergoes halogenation in the presence of heat or light to give us 2-bromobutane. And this 2-bromobutane has got an asymmetric center, right? Okay, remember, you're starting with a compound which does not have asymmetric center, and you're ending with a compound which has an asymmetric center. In general, if you come across a reaction like this, where you're not having any asymmetric center to begin with, and you're creating a new asymmetric center, it's always going to lead to the formation of racemic mixture. Okay, a racemic mixture is a compound where it has a mixture of two enantiomers. It's basically a pair of enantiomers. For this compound, for this reaction, these are the two enantiomers. Now, why it should form two enantiomers? What is the reason behind it? Now, we know that if you take a radical substitution reaction, it has to go through the formation of an alkyl radical. This is the alkyl radical that is formed. And when you look into the structure for this alkyl radical, it's actually going to be planar, where if you take this as your sp2 carbon, this is your sp2 carbon, and the atoms that are attached to the sp2 carbons, here are the atoms that are attached to the sp2 carbons. All of these are going to lie on the same plane. So the incoming group, here in this case, the Br radical can approach this carbon from the top portion, or it can approach the carbon from the bottom portion, and accordingly it can result in a pair of enantiomers. And here are the two compounds that are formed. Stereochemistry of radical addition reaction. Here is another reaction where there is a formation of an asymmetric center. Look into this reactant right here. It does not have any asymmetric center, but the product here has an asymmetric center, and here is our asymmetric center. Here again, the reaction is going to lead to the formation of a racemic mixture, and that's basically a mixture of a pair of enantiomers. Right. Now, let's take a look into the mechanism first. So in the first step, what's going to happen? The Br radical is going to get added to the carbon which has the most number of hydrogens, which is basically anti-Markovnikov's rule. And this electron is going to go onto that carbon, thereby forming this radical. And again, this radical is planar, where the atoms attached to the sp2 carbons, they're all going to lie in the same plane. Here is your sp2 carbon, right? And because of which the hydrogen, which is going to be added in the next step, can go approach this carbon in the top portion, or it can approach the carbon from the bottom portion. And accordingly, you will get a mixture of two enantiomers. What's the basic difference between the radical substitution and radical addition reaction? Both of them are going to form the alkyl radical at some point, right? Once the alkyl radical is formed, in a radical substitution reaction, it is the bromine radical which goes and gets added to the carbon, right? And again, it can go in the top portion or in the bottom portion, resulting in a pair of enantiomers. And in the radical addition reaction, the same thing happens, but here instead of bromine radical, it's going to be the hydrogen that's going to get added to the carbon, okay, thereby resulting in the formation of the asymmetric center. So both of those are going to give us a pair of enantiomers. Let's do an example where there is a mixture of enantiomers obtained, basically a racemic mixture is obtained. Let's consider this compound, and this part right here can be taken as kind of an alkane molecule, and we are going to remove this hydrogen and substitute with bromine. Okay, so now let's see what is going to happen here. Okay, this bond right here is going to break homolytically, where the electrons in here is going to go onto this carbon, and one of the electrons is going to try to form a bond between hydrogen and bromine, and this is going to create as a radical. Okay, so here is our radical. Once this radical is formed, we know that it is planar. So this carbon right here is sp2 carbon, and any atom which is attached to it, they're all going to lie in the same plane, right? So when the bromine comes in, okay, which is our incoming group, which needs to get added, it can have equal accessibility on both the sides. So basically, the bond right here is going to break and it's trying to form a bond between carbon and bromine, and the other bromine is going to leave as radical. So the product here would be a pair of enantiomer, which is going to look like this. So you have this benzene ring, and you have CH2, CH3, and then CH3. And the other product would be basically a mirror image of this because there are a pair of enantiomers.